Oh, I can see Regan. Hey Regan, you're gonna be live on camera. You're gonna be famous. Yeah, you're gonna be famous, dude. He can see you, bro.
I can hear you probably.
What?
I can hear you.
Hi, bestie.
Okay, please prepare your textbooks as well as your worksheet from yesterday. Are you that give up?
Hey, finish already ah?
Not all, but really
It's going to take a while to revise what we did yesterday.
Hey YouTube. We're gonna be YouTube famous.
Okay, today I'm going to do a quick recap of why we ended up yesterday. Okay, so far we've learned quite a few basics of chemistry. You've learned how to read symbols. For example, if I were to give you something like C, 12, and 6, you can tell me a lot of information from this, right? For example, can you tell me what's the atomic number of this element?
25.
Okay? Okay, sorry, I maybe didn't bring you up. Okay, so what is the atomic number? That's the first question. JH105 Okay, so this is the atomic number. This is what we learned so far.
I don't remember writing this.
What is the mass number? Mass number is the one on the top.
I don't know why it's like that.
number of protons for carbon? Megan? Number of protons for carbon? Sorry? What? 6, okay. Number of protons for carbon, 6. How many electrons are there for carbon? Adora? Sorry? 6, okay, 6 electrons. How many neutrons are there in carbon? Oh, sorry, flying squad. 6, okay? Okay, so we've learned quite a lot of things. Other than this, we've also learned how to express things in models as well as electronic configuration. So for example, let's do a quick test. Okay, I'm going to give you 3 elements. Everyone practice how to express it in electronic configuration. So I have one from group 1, sodium. I have another from group 2, beryllium. Another from group 13, aluminium. So everyone stand by. I'm going to ask you for the electronic configuration. Okay, for group 15, I would like nitrogen, sulfur, and fluorine. Wow, it's quite the weather. Okay, I want the electronic configuration. The more I focus you look, the more I call you up.
Jack and each other.
Okay, your turn too. Okay, ready? What is the electronic configuration of these elements? Okay, each other. Sodium. Yeah. Ryan, your next up. Beryllium. Sorry? What is sodium? Search period 3, group 1. Sorry? Try again. How wet are you? Isha? How you tell? Tell me. How you arrive at that? Don't tell me Jack told you, Jack said it. Isha, how you get 20.1? Okay, good. There's 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the last shell. Yeah? This element is in group 1. That's why we find only one electron in the outermost shell. Okay? The next beryllium. Right, ready? 2.2. Very good. Okay? This comes from group 2. So 2 outermost shell. Sorry, 2 electrons in the outermost shell. Okay, next one. Let me ask you.
Yeah.
Sorry?
Yeah.
We have problem differentiating boys and girls, huh? Rivera?
Which is why you love men.
2.8.3. Very good. That's why it's in group 13. And then, yeah. The one that didn't respond to me. Yes. Nitrogen. 2.5. Very good. The next ask as well. configuration of helium as well as neon as well as argon. Okay, 3 more like this. Helium, neon, and argon. Okay, check. Helium, electronic configuration. Sorry? Very good. Just 2 up. Next, neon. You mean neon. Sorry? 2.8. Very good. Argon. Ivan. Argon. Okay, 2.8.8. Okay, so a quick recap from yesterday. Hey, I must say, as a class, you are doing so good so far. Okay, no, so good so far. So far, so good. Okay, all of you are doing so far, so good. When I check how you do your worksheet, the progress is good. So you keep up with me and your chemistry foundation will be really strong. Okay? Yesterday, we encountered a new section of the topic on ions. At the end of the day, all the elements in each group, they want to achieve a configuration where their outermost shell is fully filled. There are 2 ways to achieve this. You either lose electrons or you gain electrons so that your outermost shell is fully filled. For example, if we look at elements in group 1, 2, and 13, is it easier to lose or gain electrons so that your outermost shell is fully filled? Okay, everyone think that. Next, for elements in group 15, 16, and 17, is it easier to lose or gain electrons so that the outermost shell is filled? Okay, ready? So 2 questions up. Is it easier to lose or gain electrons in the outermost shell so that you have a full electron shell configuration? Okay, first one. For groups 1 to 13, is it easier to lose or gain electrons? Lose. Is it right? Lose. Okay? So Sandra is right. It's easier to lose electrons rather than gain so that you have a full electronic configuration. So for example, after you lose electrons, what you're going to get is a 2.8. Can you tell me now, everyone think, what would be the overall charge of sodium after it loses 1 negative charge? Okay, yet, positive, just a positive or 2. Let's look at beryllium. After it loses electrons, you end up with just a 2. What is the charge of beryllium now? That it loses 2 electrons, 2 negative charge. EV? 2 plus. What happens when aluminium loses its 3 electrons? It doesn't mean I call you before, I cannot call you again. Huh? Okay? So when aluminium loses its 3 electrons in the outermost shell, what would be the charge of aluminium? It loses 3 negative charges. Kang Yu? Sorry? Yes, Kang Yu is right, you become a positive charge. But how much positive? This one is positive 1. Good, okay? 3 plus. Okay? Because it loses 3 negatives. So overall now becomes overall 3 positive. Okay, next. Is it easier to lose or gain electrons for elements in group 15 to 17? Okay, I think this is a giveaway. Since you already say lose on the other side, it's much easier to gain for all of them. Okay, so the task for you now is, after it gains electrons, can you tell me the charge of all these elements? Everyone will think that. So what is the charge of nitrogen? Sulfur, fluorine. I can sort of see some of you very efficient already while you are listening doing homework also. Yes? Okay? Why am I not called yet? Most people in the whole class is calling homework. Okay, so yeah, what of nitrogen? What will be the charge of nitrogen? Why it gains electrons from 5 to 8? Sorry? Right, it will be a negative charge, but how many negatives? How many electrons does it gain? That's the clue. 3 negatives, so it will be a 3 minus. Okay? Next, sulfur gains 2 electrons, so that its outermost shell is filled. What will be the charge of sulfur? Binan? What's the charge of a sulfur ion? Hey, Kyra, you will do for fluorine. Okay. Sorry? Binan? Binan, you look at the whiteboard. Look at the whiteboard. Okay. Sulfur, you understand this, right? What's the electronic configuration? Yeah? All elements, they want to achieve a configuration where their outermost shell is totally filled. Following? You see sulfur has 6 electrons in the outermost shell. How many more does it need to become full? 2 more. So this is the configuration when it has gained 2 electrons. So my question is, what would the charge of the sulfur ion be after it has gained 2 electrons in the outermost shell? What is the charge of an electron? Is it positive or negatively charged? Sorry? Hey, I will wait. So is it positively or negatively charged? Electrons. Negatively charged. So if the atom gains 2 electrons, what will be the charge of sulfur? Where's your textbook? Where's the outside? Waste your time and waste my time. Who's stand outside? Until you can think about the answer, and you can come back. Same for the rest of you. Go and take some notes. Finan, take some paper and pencil. Some, give me sulfur. 2 minus. Okay, that's good. Kyra, fluorine. Minus. Okay, so this is what we've learned so far. Last but not least, what are the names of these ions? What are negatively charged ions called? What are positively charged ions called? Okay, Ethan, which are the onions? The negative ones, so they are called anions. I don't care how you pronounce it, as long as you write it up correctly. Don't write onions. Yes. Sorry? Yeah, you can. Then this one? Okay, cation. Yeah, I need to teach you the correct pronunciation so you don't make a fool of yourself. But if you still want to pronounce it the wrong way, please go ahead. Okay, so it's ions and anions, not cations or onions.
I don't have it.
But you can if you want to. Okay? Let's watch a quick recap. So whatever I just taught you, we're going to watch a quick recap before we move on. Yes. Oh yes. If you want to take photo of anything in class, just go ahead and take. Yeah? Just not of me can already, but whiteboard is okay.
Hey, I'll start here. Yeah, if we are one class, one person could take a photo also and then you send to everyone. Okay. A quick recap of whatever we've just learned.
This lesson, we will learn about what ions are and how they are formed. When an atom gains or loses electrons, they develop a charge. Recall that electrons are negatively charged, so the gain or loss of electrons will create a charge. These charged particles are called ions. When an atom loses electrons, they become positively charged. Positively charged ions are called cations. Easy way to remember this is to recall that cats have paws. When an atom gains electrons, they become negatively charged. Negatively charged ions are called anions. Let's look at sodium as an example. Its electronic structure is 2, 8, and 1. It has 1 electron in its valence or outermost shell. When sodium loses this valence electron, it becomes a positively charged sodium ion. This charge is written as a superscript when writing the symbol. When drawing the electronic structure, enclose it in square brackets and write the charge on the top right-hand corner. Now, let's look at oxygen as another example. Its electronic structure is 2 and 6. Therefore, there are 6 electrons in its valence shell. Oxygen gains 2 electrons to form a negatively charged oxide ion. Remember to include the charge when writing the symbol and when drawing the electronic structure. If we look at the electronic structure of these 2 ions, we will see that they have a complete outer shell. We will also see that they have the same electronic structure as that of a noble gas. The sodium ion and the oxide ion have the same electronic structure as the neon atom. How are you feeling about ions? Are you ready to form ions?
Okay. I hope you noticed by now, I keep saying they want to achieve a full electron shell, optimal shell, right? Yeah. But truth be told, you notice that everyone is just trying to have a configuration that looks like the last group, group 18. Okay? Group 18 elements are called noble gases. They are like royalty, they are like nobility. Okay? Because when you look at noble gases, and you look at the number of electrons they have just the right number of electrons such that their outermost shell is always filled. Helium has 2, neon has 2.8, argon has 2.8.8, and everyone wants to be royalty. Everyone wants to be just like the royalty. So they either lose or gain electrons, so that at least in the way they arrange the electrons, it looks the same. Okay? What do I refer to these configurations as? You see an 8 over here, the word octet can be used to represent 8. The word duplet can be used to represent 2. All elements strive to achieve either duplet or octet configuration. Okay? Or sometimes the teacher may say, all elements are trying to achieve the noble gas configuration. So noble gas electronic configuration. That's the ultimate goal of all elements. Yes, Ethan? Oh, you're saying royalty, they're so up there you don't react with anyone. It's true though. Ethan is going a few steps ahead. When you look at noble gases, they don't carry out any reactions, but we'll learn a little bit more later on.
Oh my god. Sound is done.
Okay. Yes. What's the next couple? Every week we do one. Yeah, so next week we do another one. You need to learn more things, yeah. Tell you more things, yeah. Okay. Today I'm going to teach you perhaps one more important skill in chemistry. We've learned how to draw Bohr's model of electronic representation. So Bohr's model. If I ask you to draw Bohr's model for sodium, all of you are quite skilled at that. Yeah? Today I'm going to teach you how to draw another kind of model. That kind of model is called dot and cross model. This model is way simpler, saves you a lot of time, so you don't have to draw many things. Okay? Everyone okay? I'm going to erase the whiteboard. You have a question? It's not wrong. It has its limitations, but it allows us to still present information that is still useful for learning. Yeah. So it's not wrong. It has limitations. Yeah. For example, they don't all fit in one circle. Okay. Today I'm going to teach you how to draw dot and cross diagrams. This is a very important skill to pick up. Okay, so far we've learned about what kind of ions each atom can form from each group. Today I'm going to teach you how to represent these atoms in terms of dot and cross diagrams. Here's a sodium atom. Okay. This is another way to draw your diagrams. So for example, let me erase the whiteboard and we focus in on sodium. Okay, when you look at sodium, one way to represent sodium, which is very tedious, is to do this, which is what you all have been doing so far. First shell 2, second shell 8, last shell 1. Okay, but another way to represent your atoms is if we just focus on the outermost shell. Because at the end of the day, it's the outermost shell that's most interesting. It is the outermost shell where you either lose or gain electrons. So that's the most interesting part of the atom. The inside is really not the most interesting part. So another way you could represent atoms is this way. For example, I'm going to write sodium, and instead, I'm just going to put a cross. That's it. All I'm doing now is to represent the outermost shell. I don't even draw the circle anymore. Simple? Much more easy, right? If we try this for magnesium, what would magnesium look like? Everyone look at magnesium now. Okay, so first and foremost, what is the electronic configuration of magnesium? 2, 8, 2. What would a magnesium ion look like? Sorry, what would a magnesium atom look like if I just draw it in a dot and cross model? Really? Now we just focus on outermost shell. It gets simpler and simpler. Sorry? I haven't drawn yet. So Joe, how many should I draw for magnesium? Just 2, right? So very simple. 1, 2. That's all. We ignore now even drawing a circle. We ignore the innermost shells. We just focus on the outermost shell. Oh, okay, doesn't that give you less information? But the reality is that there is information we don't really need in chemistry. In chemistry, when you are doing equations next time, it's the outermost shell that is the most interesting and most useful information you need to know. Okay? Simple? So let's take this one step further. If this is what sodium looks like, magnesium looks like as an atom, what would its ion form look like? Okay, what would its ion look like? The reality is that we know that sodium will lose 1 electron, right? We know magnesium lose 2 electrons, right? And I already said that all we represent is the outermost shell, right? So if it loses its outermost shell, you know all you need to do? All you need to do is to just give me a bracket and put the charge. That's all. Okay? It gets simpler. You don't even need to draw anything on the outside because it has lost it. Alright? So if we look at magnesium, what would the outermost shell, what do you need to put? Don't need, because it has lost all 2. Okay, easy? But what you need to do is to give me the charge. So what would the charge of magnesium be? You just need to write the plus in the top right corner. Alright? Okay, so it gets quite simple. Let's look at chlorine instead. So if you look at sodium here, you see you can represent electrons either in dot or crosses. That's why we call it dot and cross model. Here I chose to use a cross. But if you like to, you can instead use a dot. So here, I could use a dot instead. I could use 2 dots here. It's up to you which one you want to use, dot or cross. That's why it's called a dot and cross model. On the screen, I show you a sodium with a dot. And this is what happens when it loses the electron to become an ion. Just like that. Simple? Yeah, very easy to write, saves you a lot of space. And therefore, you need to pay attention when the teacher asks you to draw things. If the teacher asks for a Bohr's model, you draw this complicated one. If they ask you for a dot and cross model, don't waste your time. All you need to do is really just this. Let's look at chlorine. For chlorine, I decided to use a cross. Does this make sense when I draw chlorine? Notice that I'm just using the outermost shell. Chlorine is electronic configuration is 2, 8, and 7. Look at what I've drawn outside chlorine. I've just drawn 7 crosses, that's all. I didn't even draw the shell. It is very easy to draw. Can everyone try now? If I were to then get an ion of chlorine, what would a chlorine ion look like? I'll give you a sample. Chlorine ion will look like this. Later everyone can try for many more ions. So this is what we have so far. It needs to gain an electron, right? How do we represent this? Okay, we call this a dot and cross model, right? So if you choose to use a cross, then you would need to represent the gain electron using a dot, so that I can differentiate which electron came from chlorine, which electron came from elsewhere. Okay? Then we put a charge minus, because this electron provides one negative charge. So this is how you can represent it. That is for the next week. Okay? Follow it? So this is what it will look like. So everyone, I would like you to try something right now. Let's practice. On one page of your textbook, everyone go to page 51 of the textbook. You should see one big blank space below. Okay? Could I get you to draw this table first? After you draw this table, you may proceed with using a pencil so that you can still make corrections. Using pencil, will you represent for me the dot and cross diagram for all of these ions? Dot and cross diagram for all of these ions. However, I want you for group 1, 2, and 3, can you use dots? For groups 15, 16, 17, can you use cross? Okay? So we standardize, it's easier for me to check you later on. Okay? Okay, now proceed. On page 51 at the bottom, first draw this table. After which, I'd like you to try and draw the dot and cross diagram for these ions. You can find all of these atoms in your periodic table. 51. Page 51, there's one big blank space. If you are a digital note taker, feel free to use your digital platform to do this. If you make notes in the notebook, you want to do this in your notebook, go ahead and do it. Okay? It's just that this space is quite nice. Okay, please proceed. Okay, I give you around 10 minutes to do this task. Then after that, we'll do a quick check with each other. Just realize I may have tricked you. In reality, if you realize those in group 1, 2, and 3, you don't even need to put a dot across. Correct? Because when you form an ion, it's lost it already. Make sense? Okay, look at sodium. Sodium loses its outermost 1 electron. When you get the ion, there's nothing to draw. Yeah? So you don't need to use a dot all across. I think I labeled the groups wrongly. It's a 15, 16, and 17. I have drawn on the whiteboard what the dot and cross diagram looks like for their atoms. Your task is to just give me their ions. What happens when they gain or lose? Okay, I'll invite some of you up to draw on the whiteboard. Yeah. Yes, when he loses all his dots there. Yeah, just B, box it up, and then you write up. Yeah. Okay, two sets of answers have come on the whiteboard. Yanis is doing the third one. Okay, notice after you lose electrons, there's nothing left to express in the outermost shells. You lost it. Thank you. Okay, we're left with all of the anions. Yeah, Joe, I haven't really asked you yet. Joe, do you mind doing any column in the anions? The anions. Yeah, you do. You have to show the electrons in the shell, like shown at that. Okay, Joe. Okay, as I'm walking around, I notice that for the anions, a lot of you didn't draw the electrons in the outermost shell. Okay, so look at what Joe is doing. He is trying to show that nitrogen, with its current electrons in the outermost shell, he gains 3 electrons. Right, what's wrong with this? Correct, okay, continue, you're correct. Okay, let's say for phosphorus, he's drawing such that he's trying to show phosphorus gain 3 electrons. Then it goes a 3 minus. Okay, can you double check now? I notice as I'm walking around, it is the anions that didn't write the electrons. We can do it for the cations because they've lost all of it. Okay, but for the anions, they still have it, they're just gaining more. Everyone double check. When you draw the ions for groups 5, 15 to 17, you see, right, the chlorine originally has 1, 2, 3, 4, 5, 6, 7 electrons in the outermost shell, right? It needs to gain one more, right? So that it's full, right? So you need to show that it has gained electrons. How do we show that? You see, for example, you look at sulfur. You see sulfur originally has 6 electrons in the outermost shell. It needs to gain 2 more to be full, right? So look what Binan has done below. See the sulfur, he had 2 dots below to show that he has gained 2 electrons. So I think you're missing that for nitrogen, phosphorus, oxygen, sulfur, chlorine, and chlorine. Let me check this area, quick scan. Okay. Last one. Where's my marker? Okay. Where's the done? Emily, can I get you to do for chlorine and chlorine? Thank you. Yeah, I like it when you all don't even come out with the textbook. Yeah, it shows some confidence in your skill now. Here's an interesting thing you can play. Can you actually spell your name using elements?
No.
How many elements do you need? How many symbols do you need to spell your full name? Sorry, just your name. Is that Z? There's no Z. There is only ZN. Yeah, no, this is starting with here.
There's no J. Jack.
There's no J element.
Jack.
Anyone can spell their name. You cannot. What?
No.
I do not think there's an element that's just R. There is ruthenium. R. Okay? Yeah, I don't think everyone can spell their name.
I got Singapore.
Okay? Then let's move to the whiteboard. Well done. This is what all of the dot and cross diagrams of ions look like. Okay, I will stop here for today. In the remaining 3 minutes, you can complete your RE. I would like to go through your RE the first lesson next week. Meaning next Wednesday, I will go through your RE for this chapter. You should be able to do it quite easily now. Some of you are already more than halfway done. Yeah, you are. Oh, this class is pleasant surprise. What before what?
Honestly, 105.
Okay.
Oh my god, Dusty never put on phone and we wrong podcast. So bored, I want to take pictures of people, I want to go to other people's iPads. You mean You mean? Why you so obsessed with Titan? You always take picture of him You mean it's quite obvious you have a crush on Titan?
No, I don't.
Then why would you be taking so many pictures of him? You take so many pictures of him. You mean as like a huge crush on Titan? You mean you're gonna break Sean's heart? Because you have a crush on Titan. You should only have a crush on one.
What you're doing is
Ivan, wrong person. You mean? What you're doing is not cheating.
You need to know that.
That's not my problem.
Your voices are making